Hi guys, tonight we're going to continue with estimating square roots, but this time we're going to estimate square roots to the nearest tenth, or the nearest decimal point, one place after the other. So before we were looking at, let's take a look at the square root of 12. So we want to find out what the square root of 12 is to the nearest tenth. So we know from yesterday's notes that we want the square root of 12 is between the following two perfect squares. So if we look at our list of perfect squares, and you can reference back to your notes, the square root of 12 is somewhere between the square root of 9 and the square root of 16. And we know that the square root of 9 is 3 and the square root of 16 is 4. So the square root of 12 is somewhere between 3 and 4. I want to know a little more accurately what the square root of 12 is equal to. So we're going to use multiplication to find the closest number to the nearest tenth between these two integers. So let's take a look at a number line. We know that 3 is here. We'll just mark this down, and 4 is here. 3 again is the square root of 9. 4 is the square root of 16. So if we look at 9 or 12, where it falls between 9 and 16, it falls somewhere in the middle. So the square root of 12 is somewhere halfway between 3 and 4. So we're going to guess that the square root of 12 is about halfway between 3 and 4 is 3.5. But to check to see if we're right, we're going to use multiplication. So we're going to do 3.5 times 3.5 and see if we get a number that's close to 12. 5 times 5 is 25, carry the 2. 5 times 3 is 15, plus 2 is 17. There's my placeholder. 3 times 5 is 15, carry the 1. 3 times 3 is 9, plus 1 is 10. So that's 5. 7 and 5 are 12. Carry the 1. 1 and 1 are 2. And we take that 1 down and put our decimal point in. So when we multiplied 3.5 times 3.5, we got 12.25, which is really close to this number here. So we're going to estimate that the square root of 12 is somewhere around 3.5. So really we're just using the guess and check method. So let's take a look at the square root of 42. We know that the square root of 42, by looking at our list of perfect squares, is in between the square root of 36 and the square root of 49, because 42 comes between 36 and 49. The square root of 36 is 6, and the square root of 49 is 7. So the square root of 42 is somewhere in between there. So if we look at 42, again, it's about halfway on the number line. So if we use this as our number line, the square root of 42 is somewhere right about there. So it's somewhere around 6.5. So let's check, and we'll multiply 6.5 times 6.5. 5 times 5 is 25, carry the 2. 5 times 6 is 30, plus 2 is 32. There's my placeholder. 6 times 5 is 30, carry the 3. 6 times 6 is 36, plus 3 is 39. Bring down my 5. 2 plus 0, 9 plus 3 is 2, carry the 1, and we get 42.25, which is really close to 42. So the square root of 42 is about 6.5. This, in my opinion, is probably the easiest method to estimating square roots. Okay, now let's take a look at example 2. Example 2 is the square root of 20, and we know 20 is not on our list of perfect squares. So we want to estimate the square root of 20 to the nearest tenth. So we need to find the two perfect squares that the radical fall between. And by the radical we mean just the square root of 20. And we know that the square root of 20 is between the square root of 16 and the square root of 25. The square root of 16 is 4, and the square root of 25 is 5. So that means that the square root of 20 is somewhere in here. So we're going to go ahead and make a number line again, and we're going to put 4 here, which is the square root of 16, and we're going to put 5 here, which is the square root of 25. So if we look at 20, 20 is closer to 16 than it is to 25. So if this is the midway, this is 4.5, because it's halfway between 4 and 5, the square root of 20 is probably somewhere right about here. So let's pick a number that's smaller than 4.5. Let's go to 4.4 and multiply those two together to see if we get a number that's close to 20. 4 times 4 is 16, carry the 1. 4 times 4 is 16, plus 1 is 17. Same thing again. We get 4 times 4 is 16, carry the 1, and then we get 17. So bring down the 6. 6 plus 7 is 13, carry the 1, we get 9, and so what we end up with is 19.36, which is really close to the square root of 20. So that is about the square root of 20. All right, try the next example on your own, which is the square root of 33. And then pause the video and check your answer. Okay, so the square root of 33 is between the square root of 25 and the square root of 36. The square root of 25 is 5, the square root of 6 is 36, so we know that the square root of 33 is somewhere between these two. So we're going to go ahead and draw our number line. 5 is right here, and 6 is right here. That's the square root of 25. That's the square root of 36. 33 is closer to 36 than it is to 35 or 25. So if this is our midpoint, that's about 5.5. The square root of 33 is somewhere over here. So it's real close to 6. So we're going to try, let's try 5.7. If that doesn't work, we can try 5.8. If that doesn't work, we can try 5.9. But let's keep our fingers crossed so we don't have to keep on doing that. 7 times 7 is 49, carry the 4. 7 times 5 is 35, plus 4 is 39. There's my placeholder. 5 times 7 is 35, carry the 3. 5 times 5 is 25, plus 3 is 28. So bring down our 9. 9 plus 5 is 14. 8 and 3 and 1 are 12, carry the 1, and we get 32.49, which is pretty darn close. So we want to round it to the nearest tenth, so that means the square root of 33 is somewhere around 32.5. And this one as well, we could round to 42.3. Okay, so if you have questions, please write them on the back of your paper. We're going to practice with these some more in class tomorrow so that we can get some more practice on these. Have a good night.